Now that we know what WACC is, weighted average cost of capital, and what it's used for, let's go through an example of seeing how we calculate it. First of all, let's bring back the whiteboard to just write our formula for weighted average cost of capital again. We know that the weighted average cost of capital is equal to the equity of the firm divided by the value, which is the debt plus the equity, times the required rate of return on the equity, which we find with capital asset pricing model, plus the market value of the debt divided by the enterprise value of the firm, which is the market value of the debt plus the market value of the equity, times the required rate of return on the debt, times 1 minus the marginal tax rate. So that's our formula for weighted average cost of capital. Let's go now to our class notes to see what information we have got to be able to calculate what is the WACC for a firm, Freeman Industries. So here is the information about Freeman Industries here at the bottom of page 5 of your class notes. Freeman Industries has 1 million shares of common stock outstanding. Okay, it doesn't mean they're outstanding shares. That's just how many shares are out there, 1 million shares. And they're currently trading at a price of $60.60 per share. Freeman also has some debt, publicly traded bonds. Their face value is $20 million, but the bonds are trading at 101. Now, you will recall from when we were talking about bonds that if they're trading at 101, that means their price is 101% of their face value. So if their face value is $20 million, what's their price going to be? It's going to be 20 million times 1.0 times 1.01, which is going to be $20.2 million. The coupon rate on these bonds is 8%, and they mature in 12 years. Semi-annual coupon payments, as always with the bonds. Now, the corporate tax rate for Freeman is 21%. That's their marginal tax rate. That's what they're going to be taxed on the next dollar they earn. Freeman has a beta, and of course, that's an equity beta, because whenever we see beta, we assume it's equity beta unless we hear otherwise. Has a beta of 1.1. The risk-free rate, you can get a rate of return of 3% right now with a standard deviation of 0. These are all annual rates. And the market risk premium, R sub M minus R sub F, is 5.7%. So we're going to take this information here to find out what is Freeman's WACC, its weighted average cost of capital. So we go on to our next page of our notes, and we find, first of all, what is the value of the stock? The value of the stock is going to be the number of shares outstanding times the price per share. So that's going to be $60.6 million. If you wanted to buy all the stock of Freeman, and if you could do it at the current price, it would cost you $60.6 million. What about if you wanted to buy all the bonds? Well, remember, we said the face value was $20 million, but it's trading for a price that is 101% of that. So 101% of $20 million is going to be $20.2 million. So the enterprise value, the value of the equity plus the value of the debt, if we assume there's no cash on hand, is the value of the company, which is $80.8 million, the addition of the value of the equity plus the value of the debt. So what is the proportion of equity in our capital structure? It's going to be the value of the equity divided by the value of the company, and that's going to be 75%. So 75% of our capital was supplied by the stockholders. That leaves 25% for the value of the debt, the $20.2 million divided by the enterprise value of the firm. 25% is going to be the value of the debt. Now, what's the required rate of return on the stock? For the capital asset pricing model, we already said that the risk-free rate was 3%. We said that the market risk premium was 5.7%. Freeman is a little bit riskier than your average stock with a beta of 1.1, so it should get a little bit more than the average risk premium. So Freeman's risk premium is going to be 1.1 times 5.7%. So if that's Freeman's risk premium, add to that the risk-free rate, and the total required rate of return on Freeman stock is 9.27%. So the stockholders are saying, hey, don't do any projects unless we get 9.27%. The required rate of return on the debt is the yield to maturity on the debt. So we got to go back in our memories to when we were dealing with bonds. And we know that this is the formula here for the price of the bonds, okay? And we know that the price is 101. Now, you could put $20.2 million there, and that's fine. If you do, then you got to put $20 million as the face value, and everything's going to work out. You're going to get the exact same number, okay? To me, it's easier to put the face value of the bonds as 100 and the price as 101. The coupon payment, remember, is semi-annual. So since it's an 8% coupon rate on a face value of 100, that means you get $8 per year. Semi-annually, you get $4 per year, or 4% of the $20 million. So if you had the $20 million up here, you would have to have the coupon payment as whatever is 4% of $20 million. Now, this number of semi-annual periods is 24 because it's 12 years until these bonds mature. So we've got semi-annual coupon payments, semi-annual periods. So when we solve for R, we're getting the semi-annual yield. You would do this in Excel. I'm not going to go into it now. You can go and check it. But we're using the rate function in Excel, solving for R, and that's 3.93%. When you do cell referencing and double that number, we're going to get 7.87% is the yield to maturity. So that's what the bondholders are requiring. The bondholders are saying, hey, we don't want to do, we don't want you to do any projects unless we're going to get at least 7.87% on this. Okay. Now, the bondholders really don't get a vote in this thing. Okay. But it's not going to be a problem because the stockholders are saying we don't want to do any projects unless we get at least 9.27%. So the bondholders will get their 7.87% if the stockholders get 9.27%. So to find the weighted average cost of capital, here is the equity divided by the value is 0.75. Here's the required return on the equity, 9.27%. Here's the debt divided by the value, 0.25. Here is the required rate of return on the debt, 7.87%. And here is 1 minus the tax rate, reflecting the fact that when we make these payments to the bondholders, it's tax deductible. So for us, it doesn't cost us 7.87%. It costs us 79% of 7.87%. So you do the math on there and you find the weighted average cost of capital is 8.51%. So what we've done is we've averaged together this 9.27% that the stockholders require and this 7.87% that the bondholders require, except that it is the cost of capital, and the cost to us is 7.87% times 1.21%. We've averaged them together, but it's a weighted average that we put a heavier weight on what goes to the stockholders, and we have a smaller weight on what goes to the bondholders because there's more equity in the capital structure, less debt in the capital structure. So this tells us for any projects that Freeman is doing, okay, where the cash flow is free cash flow, meaning it goes both to the stockholders and the bondholders, the appropriate discount rate to use is 8.51%, the weighted average cost of capital. Now, you don't use this if the cash flows all go to the stockholders. If the cash flows go all to the stockholders, you use 9.27%. If you've got some sort of a project where the cash flows all go to the bondholders, you don't use that. You're going to use the 7.87%. So this is for projects where the cash flows go both to the stockholders and the bondholders when we're dealing with free cash flows. So that's going to be the cost of capital. Okay, it's a weighted average cost of capital. It's going to be the cost of capital that Freeman will use in evaluating projects that are of the same level of risk as other projects that Freeman has been doing. Now, let's suppose we have a project that you say, yeah, I know my WACC is 8.51%, but I'm going to be borrowing money to do this project, and all the money I'm borrowing is what's going to be invested in this project. Should I still do it at 8.51%? And the answer is yes, because the firm is still owned by the stockholders who require the 9.27% there. Now, here's the thing, though, that if by borrowing for this new project, it causes Freeman to have a change in its capital structure. In other words, if you take on so much debt for this project that it's no longer 25% debt and 75% equity, you use the new capital structure. Okay, now that's going to be a big project. If a project is big enough and requires enough debt, or if it requires additional equity, that it changes the capital structure of the firm, use the new capital structure. We're not going to have any examples like that in this class, but hey, that happens sometimes if you have really big projects where you have to issue additional equity, or you have to do some additional borrowing so that you no longer have what used to be the capital structure. You use the new capital structure of the firm and the new proportions in there. So that's something to consider. So here's Freeman now. They've got this project, okay? They want to open up a new office, let's say in New Orleans, and it's got the same risk as the company as a whole. And these are free cash flows that are coming out, okay? So we should use the WACC. So at time zero, it's going to cost Freeman $114 million. That's cash outflow at time zero. And then at times 1, 2, and 3, they're going to be bringing in $45 million each of those years. So what is the net present value of this project? Since these are free cash flows that go to both the stockholder and the bondholder, we're going to use the weighted average cost of capital. So here's the net present value. There's cash flow at time zero, cash flow at times 1, 2, and 3. And the value of R, the discount rate, is going to be the WACC that we just found at 8.51%. And we find that the net present value is $916,942. I could have taken out to the pennies as well, but I didn't here. So it's a positive net present value. So Freeman should do the project. Now, the IRR, in other words, if the IRR is going to be 8.95%, meaning that if I set net present value to 0 and made this 1 plus R, 1 plus R squared, and 1 plus R cubed, and then solved for R, R would be 8.95%. And let me encourage you, by the way, do these in Excel. Make sure you get the same numbers as I've got here. So we want to do the project both because it has a positive NPV. We know we do all projects as a positive NPV, and the IRR is greater than our cost of capital. And this is one of those basic investment projects where you have a negative cash flow followed by positive cash flow. So there's only going to be one IRR, and the decision rule is do the project if the IRR is greater than the cost of capital. Now, what you need to understand on this, okay, and this is a subtle point, but it's a very important one, that if this project makes more than 8.51%, it means that we are giving the bondholders exactly what they require, 7.87%. We're not giving them 8.51%. We're giving them 7.87%. That means there's going to be 9.27% available for the stockholders. Students miss this sometimes. They say, wait a second, the project is making, we've got an IRR of 8.95%. The project's making 9.95%. Why are the stockholders wanting to do that project? Because if the bondholders aren't getting 8.95%, okay, the bondholders are only getting what they require, okay, which is going to be the 7.87%. Anything above that spills over to the stockholders. So if this project has a positive NPV, well, first of all, for a zero NPV project, if it was a zero NPV project, then the bondholders would get 7.87%, and the stockholders would get exactly 9.27%. So let me say that again. A zero NPV project means the bondholders get 7.87%, the stockholders get 9.27%. Average them together, those numbers together, and you get the 8.51%. So the 8.51% discount rate allows the bondholders to get 7.87% and the stockholders to get 9.27%. So if a project makes more than 8.51%, we're still only paying the bondholder 7.87%. So what's left over spills over to the stockholders. How much is left over? Well, in this case, what's left over is $916,942. That's what a positive NPV means. A positive NPV means we've got enough money to pay the bondholders what they require, and we've got enough money to pay the stockholders what they require, and we've got some left over. Now, what's left over, who does it go to? It goes to the stockholders. We don't give the leftover to the bondholders. The stockholders are the ones who are taking all the risk here. So the bondholders, they're taking the majority of the risk. So the stockholders are going to get what's left over. So the stockholders make their 9.27% plus $916,942. That's why the stockholders want to do the positive NPV projects. This particular project, there's enough money so that the bondholders will get 7.87%. The stockholders will get 9.27%. And there's an additional $916,000 that goes to the stockholders. So the stockholders are going to say, yes, do the project. It makes what we require based upon the level of risk. And then it makes more than that. So we definitely want to do it. In any positive NPV project, that's why you want to do it, because it's going to give the bondholders what they require, and they get paid first. And there's enough money to give the stockholders what they require, and there's more money on top of that to go to the stockholders. So we want to do the positive NPV projects there. So hopefully this is giving you a good idea of what we're going to do in a typical situation where you have got free cash flow, where there is where the cash flow goes to both the stockholders and the bondholders, and for a project that has the same level of risk as the company, we're going to use the weighted average cost of capital as the discount rate to discount those cash flows there.